This is a short review of colligative properties of electrolyte solutions. And the key concepts to remember here is that these properties refer to vapor pressure, freezing point, boiling point, and osmotic pressure that change as a result of the presence of a solute in solution. Four equations that we need to consider are, first, that one for vapor pressure lowering, in which the change in pressure is related to the number of particles per mole, the mole fraction of the solute, and the pressure of the solvent, the vapor pressure of the solvent. The second property is that of freezing point depression, in which the change in the freezing point corresponds to, again, the number of particles per mole, a constant, and the molality, which is defined as the number of moles per kilogram of solvent. The third colligative property is for boiling point elevation, or change in the boiling point temperature, which is equal to the number of particles per mole, a constant, and the molality of the solution. And the last one is that of osmotic pressure, represented by pi, which again is equal to the number of particles per mole, the molarity of the solution, or moles per for liter or volume of solution, the ideal gas constant R, and the temperature in Kelvin. So we're using these basic concepts to define qualitative relationships in the following problem. In this problem, the idea is to rank, in order of decreasing osmotic pressure, boiling point, freezing point, and vapor pressure, three solutions. One is 4 molal urea, 0.04 molal urea, 0.01 molal silver nitrate, and 0.03 molal copper sulfate. Take a few minutes to think about this problem, propose a solution, solve the problem. If necessary, pause the video, and then let's compare our solutions. To solve this problem, first we need to determine the total concentration of ions or molecules in solution. Then we use the laws of colligative properties to determine the relative changes, and we can group them in two types: osmotic pressure and boiling point, because both of them increase when a solute is present, and B, freezing point and vapor pressure, because both of them decrease when a solute is present in solution. So let's begin then by determining the number of particles or ions or molecules in solution. Urea, which can be represented as gives in solution 1 mole per mole that was in the solid state. So I equals 1. That means that the total number of particles per mole of urea is going to be the same. That implies that 0.04 molal urea is going to be resulting in 0.04 molar urea in solution. Silver nitrate when it's brought into solution, yields a silver ion plus a nitrate ion. I equals 2. That means that the concentration that we had before is going to be multiplied by 2 to give a total concentration of ions of 0.02 molar silver nitrate solution. And the third one is copper sulfate, another salt. When it's brought into solution, gives copper 2 plus aqueous plus SO4 2 minus aqueous. I equals 2. So for the concentration given of 0.03 molar copper sulfate, in solution we are going to have 0.04 molar copper sulfate aqueous. So what we need to do then is keep in mind the following, that this corresponds now to the number of particles that are in solution, concentration of particles in solution. 0.04 for urea, 0.02 for silver nitrate, and 0.04 for a correction here. This should be not 0.04, they should be 0.06 molar copper sulfate. Now that we have the concentration of particles for each solution, we can basically look at the definitions of colligative properties and determine how these are going to be affected by the concentrations. So we need to find those that have the lowest change possible. So for osmotic pressure, and boiling point increase, we see that the one that has the lowest number of particles is going to be silver nitrate. So if we represent osmotic pressure by pi, it's going to be less than that of urea and less than that of copper sulfate. And for boiling point, the same relationship will apply. The other set of colligative properties, which is the freezing point and vapor pressure, we'll see that this is going to decrease as the concentration of particles increase. So the relationship is going to be exactly in the opposite trend. So freezing point is going to be, for copper sulfate, is going to be less than that of urea, less than that of silver nitrate. And vapor pressure will maintain the same relationship. And this concludes the qualitative assessment of the changes that we have in 3 different solutions. Doesn't really matter if they are ions or molecules that do not dissociate. The colligative properties will indicate that there is a change in these properties as a result of the presence of a solute, regardless of the nature of the solute.